Hi, hello everyone. In this video, we'll talk about the history of atomic theory. Atoms. Atoms, it came from a Greek word which means indivisible or not to be cut. Atoms, it is the origin word of atom. All of us, we heard about the atom, which is the smallest component of an element. So the original word of atom, it came from atomos. Atomos in Greek means indivisible. We want to talk about the atomic models, first of all. First of all, what's a model? Scientists, when they want to talk about something, they materialize it in a model familiar to them, to explain something which is not familiar to them. Like if we have to look here, this is the Bohr model of atom. So he used familiar idea to explain something which is not familiar. In this model, the nucleus is orbited by electrons, as you can see. This is the nucleus, and around the nucleus orbits containing electrons. So this model uses, as we said, model uses familiar ideas to explain unfamiliar facts. But models, we can't discard them at any time. However, if there is new information or something that is collected which disagree with the previous observations, we can always change the model or modify it. Atomic model. The atomic model has changed throughout the centuries. As we said here in this video, we will take the history of the atomic model. We will navigate through the history of the atomic model. Starting in 400 BC, when it looked like a brilliant ball. This is how they used to think the atom, like a brilliant ball. This is the Greek philosopher Democritus, who started to search for description of matter. He looked around, he found all matter around him, and he wanted to know, this matter, what's inside it? This happens more than 2,400 years ago. He wondered, he asked himself, could matter be divided into smaller and smaller pieces endlessly without any limit? Or there is a limit to the number of times a piece of matter could be divided? This was his main concern and question. He proposed a theory. He said that matter could not be divided into smaller and smaller pieces endlessly. Eventually, the smallest possible piece would be obtained. This piece would be indivisible, which is the atomos. He named the smallest piece of matter atomos, which means not to be cut. According to Democritus, atoms are small, hard particles that are all made of the same material, however, with different shapes and sizes. Atoms are infinite in number, moving and capable of joining together. Continuing with the Democritus theory, this theory was ignored in reality. It was forgotten for more than 200 years. Why? Because there were notable philosophers at that time, Aristotle and Plato. They had another theory. Both philosophers, Aristotle and Plato, they favored that earth, fire, air, water approach the nature of matter. So all matters made up of these four constituents: earth, fire, air, and water. So this stone made up of this rabbit made up of this. And their ideas, unfortunately, at that time dominated because of their eminence as philosophers. The atom's idea was buried completely for about 2,000 years. But later, other scientists will come to more experiments and tell us what's inside the atom. So we started with Democritus. After this, we will go to Dalton to see what he discovered and what was his theory, then Thomson, Rutherford, Bohr, and then the modern scientists. John Dalton, actually, he is an English chemist. He performed a number of experiments in the early 1800s that eventually led to the acceptance of the idea of atoms. What was his theory? He said all elements are composed of atoms. Atoms are indivisible and indestructible. atoms of the same element are alike. If we have to take a look at oxygen atom, they are here depicted in blue, here depicted in red. So as you see, the hydrogen, all the atoms of hydrogen are alike. But when it comes to other elements like oxygen, atoms of oxygen differ from the atoms of hydrogen, but each element has its own similar atoms. And then he mentioned also that compounds are formed by joining of atoms of two or more elements. So two or more elements, they join together to form compounds. Moving to Thomson. Thomson, he suggested a model that we call it plum pudding model. In 1897, this English scientist J.J. Thomson provided the first hint that an atom is made up of even smaller particles. So he's talking about now subatomic particles. Subatomic particles. He wants to know what's inside this atom. He thought, Thomson, J.J. Thomson, he proposed a model. He thought that the atom, all of it is positivity everywhere, and electrons are embedded in between, like raisins embedded in a pudding. This is what he thought, and this is what he proposed, J.J. Thomson. So he proposed a model of the atom. We call it plum pudding. Atoms were made from a positively charged substance with negatively charged electrons embedded inside them like raisins in a pudding. Experiment was done, cathode ray experiment. He studied, Thomson, the passage of an electric current through a gas. So, allowed current to pass through a gas in a cathode ray tube. As the current passed through the gas, it gave off rays. These rays are negatively charged. Look how they deflected to the cathode side, which is positive. So the charge here must be opposite, which is negative. So Thomson got surprised because the atoms of the gas that he used, they were not charged. So from where the negative charges emerged? He concluded that the negative charges must come from within the atom itself. This means there are particles smaller that they are inside the atom. He called the negatively charged particles corpuscles. Today we call them electron. Since the gas was known to be neutral, so there must be positively charged particles in the atom, but he didn't find them. After this, Rutherford came and continued in what the other scientists started. Rutherford, what he did, the following. He selected a thin foil, gold foil, and he bumped this thin gold foil and with alpha particles. The alpha particles are positively charged. They are actually helium particles. They have 2 units of positive charge. This is the nuclear charge. And they have 4 units as a mass. This is the mass. Alpha particles emitted from radioactive elements like radium and polonium. The fast alpha particles have considerable amount of energy. They can penetrate through the matter. So let us take a look. This is the experimental setup. As you see, this is the gold foil. This is the alpha particles striking the gold foil. And as you see here, we have several rays. Some rays deflected, some rays continue straight, other rays bounced back. What does this mean? Let us see his observation. Most of the alpha particles pass straight through the gold without any deflection. Look. No, this is deflected, sorry. This one passed without any deflection, which means later on he will conclude that the majority of the atom is empty. A few alpha particles are deflected through small angles, few are deflected through large angles. So also there were some deflections. and very few they bounced back. So what he concluded about this? He concluded that most of the alpha particles, because they passed straight, so the majority of the atom is empty. Some of the particles are deflected through small and large angles, so there should be positive center in the atom which repel, because positive and positive, they repel each other. So the majority of the atom is empty. There should be something here in the middle that contains positive charge because of the deflection. Very few alpha particles completely rebound, which means that all positive charge and mass of the atom concentrated in a very small volume of the atom, which is the nucleus. So atom is, as we said, we explained this. The nucleus surrounded by negatively charged, the electrons are revolving around the nucleus, as we said, in a circular path. Atom is electrically neutral. Why? Because the number of protons should equal number of electrons, or they are equal. And the size of a nucleus is very small as compared to the size of the atom. So Rutherford till now, he discovered that there were positive charged subatomic particles inside the nucleus. But what is the drawback of Rutherford model? First of all, he didn't explain the stability of the atom. The negatively charged electron revolves around the positively charged in circular path. This means that the motion of these electrons should be accelerated. And if a charged particle undergoes acceleration, it must radiate energy in a continuous way. Thus, the energy of revolving electron will decrease gradually, and the speed also will decrease by time. And hence, electrons fall into the nucleus, and the nucleus should collapse. But in reality, the atom should collapse. But in reality, atoms do not collapse. Why? Now we will move to Chadwick. Chadwick, he was the one who discovered the neutron. Neutrons inside the nucleus are the main reason why the atoms are not collapsed. This is the nucleus inside it, proton positive. Neutron, we will see they are neutral. But as we know, positive, all of them, they repel each other. So this should cause collapsing to the atom. But Chadwick came and did experiment to prove that the presence of a neutron inside allow the protons to hold to each other, and the atom do not collapse. So alpha particles, as per his experiment, alpha particles are projected toward a beryllium target. The emitted particles from the beryllium fell on an object, we call it paraffin. Once it fell, or the wax, where it fell on the paraffin wax, it released another type of particles that they are protons. But what went through the beryllium were uncharged and similar mass to protons particles. We call them neutrons. After this, another scientist, Danish scientist Niels Bohr, in 1913 proposed an improvement. In his model, he placed each electron in a specific energy level. What he proposed, Bohr, in his model, he proposed the following. Electrons in the hydrogen atom move around the nucleus in a certain allowed circular orbits. The allowed orbits corresponds to the principal energy. Like, for example, if this is energy level 1, energy level 2, no electrons in between the energies. Simply, if we think of it like this, energy level 1, energy level 2, 1, 2, 3, no electrons exist here, either energy level 1, 2, or 3. And the first energy level the first energy level, we call it ground state level. We call it ground state level. So in his model proposed, as we said, the following: the electrons and hydrogen move around the nucleus only in a certain allowed circular orbits. The allowed circular orbits corresponds, as we said, to the principal energy level 1, 2, 3, n equal 1. We call it the ground state, and n equal if infinity refers when the electron already escaped these orbits. The energy in a given orbit, there are energy levels. How to calculate the energy? It's minus 2.178 times 10 negative 18 joule. We will use them a lot in solving problems over n squared, where z is the nuclear charge and n is the integer representing the principal's energy level. After Bohr came the modern scientists that they talk about, and they proposed the wave model. Today's atomic model is based on the principle of wave mechanic. According to this theory of wave mechanics, electrons do not move about an atom in a definite path, like what they suggested, the scientists before, planets around the sun. In fact, it's impossible to determine the exact location of electron. The probable location is based on how much energy the electron has. According to the modern atomic model of an atom has a small positively charged nucleus surrounded by a large region in which there are enough electrons to make the atom neutral. A space in which electrons are likely to be found, this we call it the cloud, an electron cloud. So around the nucleus, electron cloud, as we said, that it's hard to detect. Electrons whirl about the nucleus billions of times in 1 second. They are not moving around in random pattern. Location of electrons depends upon how much energy the electron has. So upon the energy has, they move up to higher energy levels. Depending on their energy, they are locked into a certain area, as we said, in the cloud, because we have different energy levels. Electrons with the lowest energy level are closest to the nucleus, and electrons with the highest energy are found in the outermost energy levels, further away from